Welcome back. The first type of reactions that we're going to learn are synthesis of alkyl halides. Now, what are alkyl halides and how do we produce them? What are the two reactants we have to react together to make that happen? When an alkane, we all are familiar with what an alkane is. We're not talking about any specific alkane. The family of compounds that are part of alkanes, when they react with halogens, the reaction yields alkyl halides. Now, I have already spoke to you about in the previous video the stability of carbon containing single bonds, and that's what all alkanes are. When a carbon only contains single bonds, and we talk about our compound may contain double bond, but we only talk about the carbon that's containing all single bonds around it as primary, secondary, and tertiary. Okay, and I have spoken to you about the stability. The reactivity is also in the same category: primary, secondary, and tertiary. So primary free radical is less reactive than a secondary free radical than a tertiary. Why is that the case? Because only when it is more reactive, it would want to achieve the most stability. If it is least reactive, it doesn't want to be more stable. Okay, so the reactivity is in terms of the reaction being happening, and stability is in terms of the product that's formed as a result of the reaction. Okay, reactivity has to do with the reactant itself, because it has to be in a certain form for it to be very reactive. And generally, tertiary carbons are more susceptible to act quickly, which means it quickly can create a stable product. Does that make sense? So stability has to do with the product itself. Reactivity has to do with the reactant itself. But either way, the idea of primary, secondary, and tertiary stays the same. So how do we go about it? But before we actually get started, let's say we have an alkane like this, okay? But first we have to talk about something else, which is free radicals, okay? Which is, this is a halogen, which is Br2. The same reaction can also be carried out with Cl2 or I2, which is iodine, or fluorine, okay? I'm doing with bromine here. When bromine, in the presence of light, yes, that's how we write light in chemistry. You don't write the word light, L-I-G-H-T. You do write it as H nu, which is Planck's constant, and multiplied by frequency, which is nu, which is a Greek letter for frequency. When that happens, well, if you think about it from your general chem, Br is attached to another Br through a bond, right? You need two electrons to make a bond, or you need a bond to combine two electrons, however you want to think about it. Now, when bromine reacts with light, it generates two free radicals. Now, there is very unique about free radicals, because when a bond is broken in a free radical reaction, you have two partial arrows, okay? I don't think I did a very good job. Let me redraw it. It's not, this is a single arrow. When a reaction involves a free radical, it involves two separate arrows. So what that means is we will have two Br radical. What is a radical? An odd electron, okay? So what has happened here is this Br has broken in the presence of light, okay? This is the actual reaction. I'm just showing you the mechanism on the side. We will not learn mechanism for every single one, because we will learn some of that in organic too, but this is important. So this is called an initiation. The easiest way to remember is when you have a molecule that is whole and it gets broken into free radicals. So a molecule to free radical, whenever you make a free radical from a molecule, that's initiation, because that's the first step in the process. Now let's have, say, an alkane. Say this is an alkane, right? It's propane, right? So now let's actually write it as CH3, CH2, and CH3, right? That's how it's written. Now this Let's write it as CH2H because that's what this is, right? A CH3 is CH2, carbon attached to 3 hydrogens, right? So what I did is I only wrote one of them attached to CH2. It reacts with one of the free radical. Now what happens here is this bond between the CH carbon and this hydrogen, it's broken in 2 pieces. So what happens here is when a bond is broken into 2 pieces, one electron goes with the hydrogen, the other electron stays with the carbon. So what happens now is this odd electron now combines with this odd electron from a hydrogen. So basically you're left with CH3, CH2, CH. Don't put the odd electron on the hydrogen, put it on the carbon because this hydrogen is not attached to this hydrogen, it's attached to the carbon, plus HBr, right? So whenever this odd electron from a hydrogen and the odd electron from Br, so this is called propagation. That is, whenever a molecule reacts with a radical. This is the way you're going to remember this. We're going to do a couple of examples in the next video. In terms of time constraint, I'm going to keep this video to itself, okay? So this is molecule plus radical. There are so many combinations we can do with it, but whenever a molecule, like a whole molecule, reacts with a radical, that's propagation. Now when you have 2 free radicals, say you made this, there's probably thousands of these in the medium. So you have one CH3, CH2 dot, plus, you know, we don't just make one. There's probably countless of these in the reaction. These 2 react with themselves. Remember, whenever a free radical is made or formed, you cannot use a full arrow. So this reacts with this. So you end up actually making CH3, CH2, CH2, bond CH2, CH2, CH3, right? So essentially you've combined these 3, so you've made hexane. You started with propane, you made hexane. This is called termination. When 2 free radicals react, free radical plus free radical. It doesn't have to be the same molecule. When 2 free radicals react, it's called termination. So a molecule to a free radical is initiation. A molecule plus a radical is propagation. Free radical plus free radical is termination. I said multiple combination, right? We made Br dot. There are probably countless Br dot in the medium. This can react with another Br dot. So whenever a radical reacts, you don't use full arrows. This can result in Br2. Okay. Now this is not everything. So all I want you to take away from this is about the 3 steps: initiation, propagation, and termination in a free radical reaction where Br2 reacts with light. We are going to apply this logic to create multiple compounds, and then I'll leave you with a practice in the next video. This video is primarily, so you see we have we have generated this, right? This carbon contains 2 hydrogens. So is that a primary, secondary, or tertiary? Good, it's a primary radical. So you say 1 degree radical. Now this is less stable compared to a secondary or tertiary. In the next video, we are actually going to generate few combinations of, once you make this, what and all happens to this itself. You see, we've generated this with this mechanism, right? What this goes through and how we can generate a secondary from it, a tertiary from it. All of those will be the key component of the second video. But here, I just want you to take away, when you take a molecule and you make radical, that's initiation. When you take a molecule and react it with a radical, there's so many combinations possible, that's propagation. Again, when 2 free radicals react, they don't have to be identical. You know, there could be different combinations. That would be termination. All right, but I want you to understand, so this is the least stable. Remember, primary is the least stable. and then it's also the least reactive. So this is a primary radical because this carbon contains 2 hydrogen and an odd electron. We're going to see about secondary radical, tertiary radical, and see different combinations in the next video. All right, so stay tuned for further videos.